laptop list, you basically hunt a whole pile of details down and begin to get a little bit more confidence that it will work. Then you download, potentially, download new driver, compile it, work through compatibility issues with your existing distribution and so on. Okay, then cross your fingers that it's going to work and that the driver's at the maturity level that you're wanting. And then, worst case, you hope for a good return policy. Okay, what you're really doing historically for the Linux community is that you're relying on the community itself to post blog entries, push things into wikis and so on, so that people can understand whether or not the hardware works. Okay. Over time, and we're sort of at a fairly good stage now, so we've got a lot of new technology coming in, and the IHVs, OEMs, and others have really started getting a solid understanding for what sort of timeframes they need to push the hardware to the distributions. The distributions are being very receptive. Your backporting changes, enabling hardware, so that you get a CD. If it's brand new hardware, you may not have it working, but for the most part, 6 months after the release of the hardware, you're almost guaranteed to have a fairly good experience when you plug the hardware in. Okay. Obviously, the relying on Google to make a purchasing decision isn't necessarily the best thing though. Okay, hardware compatibility lists. Has anyone here used a hardware compatibility list to drive a decision? Okay, did you ever wonder what was behind the certification? Okay. It gives a level of confidence, but the certification is usually driven by the OEM or someone similar, or IHV or particular purpose, going through the certification process for the distribution vendor, be it Canonical for Ubuntu, Red Hat, OpenSUSE. Different companies will have the certification process to allow hardware to be certified. Sometimes it's to use this particular piece of $100,000 back-end server hardware. You need to have a Red Hat certified system, which means the system has to be certified, and so there's all sorts of gates within the community. Okay. What the certification really means, though, is it kind of works. It works for the purpose that it was certified for. So in the case of VGA, in the case of graphics, there are a lot of systems that are certified as working, but that's with the VGA driver or the VESA driver. Okay, it's not really what a lot of people would be expecting, but it depends on the background for the certification process and what sort of hardware goes through as to whether or not it's going to be, or make sure 3D works. A 3D workstation area certification does mean that. In a server area, or if you're looking at compute, you're not going to really have the focus on the video performance. Okay, so again, HCLs or hardware compatibility lists do provide some value, but it's not really sort of the be-all and end-all.
And plus, some of this lists, like Canonical's from like 2 weeks ago, there's only 1,400 components and like 20 graphics cards, and it's all relying upon one team within Canonical to basically produce that list. So it's of limited benefit without leveraging the community.
Yeah, so when we're starting with the open benchmarking, we were looking at, okay, so how do we actually get the information that we've been picking up from the Phoronix test suite and make it useful and compelling for people to interact with the data to understand what's going on. So going back to the original scenario where you Google for some results, with the open benchmarking, what you can do is you do a search for a product, and you can see there are a collection of results in open benchmarking for the particular hardware. So you can begin to get a more concrete feel as to whether or not the hardware is working in a way that you'd expect. So these were searches actually done over the last 2 days, just on the data that has been made available since the Phoronix test suite 3 was in beta. And so 4870, ATI graphics card, it's run on a whole pile of operating systems, number of kernels, you've got different driver choices, different X servers. So you could look at that, you'd have a fairly good feel that this particular product can be made to work for a fairly broad collection of systems. Historically, you're basically having to look at individual sort of stream of consciousness wiki articles from different people saying, I tried Red Hat this version, then I had to go get this and get that, and so you've got these Franken systems where you have to go and compare against different ones and make sure they're all about the same time, similar kernels, and so
on. Also, with these, we're also leveraging price information in real time from Amazon and other pricing partners. With each of these lists, they're being sorted based upon how many people are actually using the said kernel or driver or distribution. And then, we're pulling in all sorts of other information as well. And over the coming days and weeks, you'll see a lot more data too.
So if people have looked at graphics cards, you can see that there are a number of manufacturers that rebrand a number of products. And so you look at, say, people talk about the ATI graphics card. Okay, there's literally 10, 15, 20 different types of cards, all branded slightly differently with from different people. And what Michael has in the background is he's been pulling in the basically industry press and other hardware information for the last...
Going back to 2004, even before Phoronix.com was founded.
Yeah, and so we've got a huge amount of information that actually allows us to look at a piece of hardware and go, okay, what is this hardware, what's the sort of the vendor space around it, and begin to pull information out. Okay, as we're going through, feel free to, when the top title changes, like does it work, feel free to throw your hand up and ask some questions as well. We've got a lot of other details that we're going in as well. Okay. So once you do the search and you can see that there's a whole pile of different tests that have been run, then you can begin to dive down into some of the actual tests. Now, open benchmarking is designed to be a collaborative system where people post tests that they've done. So as it was launched today, and we've had 2 or 3 dozen results already start going through. So people are already beginning to push data in there. And so depending on what people are doing, there'll be different benchmark runs, either comparing different compilers, different graphics cards, different CPUs, different kernels. Okay, so for each of the results that are pushed into the database, you'll be able to see those relative to the search. Okay, what I've done for the next few slides is taken some of the pages and broken them down, so we can weave the way that this is actually useful for the community and the people looking for hardware. So one of the systems that we use here, and it appears fairly regularly within the article, is a System 76.
Servo Professional, one of their new notebooks based upon Intel Sandy Bridge CPU with an Intel SSD and NVIDIA Fermi graphics.
Okay, so this actually, it is actually quite useful using this one because there were a couple of things that popped up in the testing that we're doing, which actually showed us that we're on the right track. Okay, so Michael's done a number of tests on here. So we've got compiler, scalability. It's a 6-core system with micro-threading. So some of the decisions that people may be talking about is, well, 6 cores doesn't really add much value. So we've got lots of data that allows us to sort of dive into that and understand what's going on. Okay, so switching over to looking for the Sandy Bridge-based product. So you've got a set of different benchmarks. You can decide which one you want to go through and begin to explore. Okay, there's also news articles, obviously because it's been developed as part of Phoronix. We've got the Phoronix articles that are associated with the hardware, but also general industry press. Okay, and that gives, again, the opportunity to understand where the hardware sits in the bigger world and make sure you're making the right sort of decision. Okay. Obviously, Phoronix Test Suite has been focused heavily on benchmarking. The website's up in benchmarking.org, and so as you explore results, you'll see data in lots of different ways. Okay, and so
Cell phones.
Cell phones?
Here's mine.
Okay. So these are some of the views. So this here is looking at the graphics performance, and so you've got the Sandy Bridge graphics core. You've got some ATI hardware with Catalyst, you've got some open source drivers, and you can look at the relative performance. So what you're getting from this particular graph is the graphics for this particular game, and again, depending on where you're coming from, you may look at gaming, you may look at HPC, you may look at performance in different areas. So you can see that you've got performance, it's a fairly good performer in this particular game. It's slightly faster than a lot of the open source drivers, and it's also got, So you can begin to get a feel for the product. There's some other graphs. This is really just showing what is possible as well, and some of the other results. People can construct their own benchmarks and push it up. This happens to be the spec viewperf results for a set of workstation cards. There's probably about 7 or 8 different ways of presenting the data.
Oh, yeah, there is.
Yeah. Sorry?
What I'd love to see is a plot, like an XY plot of energy use and its, the impact on battery life versus performance, and see which ones are the best in that space. I mean, is this all about speed, or is anything about energy?
No, there is support within the Phoronix test suite for monitoring not only your battery power, but your thermal performance as well for CPU temperature, even your fan speeds if you really cared about what your fan speeds were running at, like the percentage-wise, and pretty much anything. There's also functional tests and other sorts of image quality tests as well.
Now, that particular area is fairly hard because it's what you actually measure is the battery life during a test. There are, as Michael said, there are a way that we can track the information, but presenting in a way that is usable across multiple people is actually quite hard. Feel free to contact us if you've got some more sort of concrete ideas. We've got all the data, it's just finding ways to present it and munge it to actually give some useful information. Any other questions before I continue? Yep.
Is this just hardware inside the case, or does it also cover things like peripherals, like printers?
It does support USB devices and other devices. Obviously, you're not going to run like a graphics benchmark on your USB mouse or anything like that. But we are monitoring all the trends for attached USB devices, whether they're web cameras or mice or scanners. And so from there, we're able to start plotting trends as well for, hey, is this device used a lot on Linux? If so, what distributions? Or is it used under BSD as well? And just all sorts of information based upon the collective power of the community.
So it's an area that we're looking at expanding into. Later in the presentation, talk about the qualification suite. And as part of that for peripherals, obviously disks and other devices where you can sort of benchmark and get a confidence there. But for printers, and once you move into sort of some of the other hardware, you've really got the choice of either having a test which is a lot harder to construct, or relying on sort of visibility of, okay, so people have done lots of tests with this hardware, and we know that they have got this USB device connected to the system. So you may have some, it increases the confidence that it may work if the people are doing Linux benchmarking and they've got, say, a particular printer attached. Okay, but a lot of that, it's again very hard to do, but we're looking at ways that we can certify, or not necessarily certify, but at least do a functional test of devices. So discovery, see if devices have got the drivers attached, those sort of things.
And it's not at all just about only hardware, but we also look at software as well for your kernels, so you can do compiler comparisons, graphics driver options, and all sorts of things.
Okay, so
Yep.
Yeah, so kind of options. How do you account for misconfigurations or
when you upload your results, you have the option of attaching all of your system logs as well. And so then once lots of users are uploading results for a given test, you can start looking at the system logs and see where the differences are to isolate either performance differences or misconfiguration and things like that. And behind you?
Yeah, so you've been talking about this open benchmarking.org as a resource to make better purchasing decisions. Do you also see an opportunity for that to be a resource for hardware makers, maybe not so much them, but system builders? It seems like they should be interested in this data.
We have many evil plans. Don't worry about that. So as we go through some of the other things, we've got some actually really exciting and innovative ways of presenting the information, which really does sort of get to your sort of questions that you're asking about sort of the overall sort of hardware ecosystem, where systems lie relative to each other, how do you make the sort of right bang for the buck decision. So stay tuned. Okay, any other questions? About to sort of change tack fairly heavily into sort of how you can tactically really get some benefits from the data that we're getting. Okay, so this top graph here this is really the data that was put into open benchmarking as we're doing the development, but as we started playing with the data, we could see that we were getting some really useful information. So if you look at this is just a histogram of the scatter plot of time and the results for a particular benchmark. Okay, so.
And that's for the results globally across everyone that's uploaded results to openbenchmarking.org for that given test and the given test option, say running a certain game at 1920 by 1080.
Yep. Okay, and so if you look down there and you say for 3 months, you look at what is the frequency of particular performance, and you really begin to get a snapshot of what the market's currently doing. Okay, and so the general way that people would present that is you'd come up with a histogram. Okay, so we looked at the histogram, and people have looked at the sort of the results that global.phoronixtestsuite.com provides, and some of the graphs that appear within Michael's report, Michael's articles. Having a lot of graphs, you've got a lot of data to interpret over a large set of physical space. So either multiple pages or just a page that keeps going on and on. So what we took is the histogram, and we sort of turned it down. So you're looking down the top of the histogram, so you can get a feel for the height of the peak. So you can look at this one and say there are a large number of systems that are in this performance range. So then what we've done is you can then snapshot a whole pot of results and go, okay, this is where this performance actually sits across this particular set of benchmarks. Okay, digging a little bit deeper, so we've got the 33 percentile, 66 percentile. For a particular system that you test, you end up with a rank of performance. And so you could class this as low, medium, and high performance. Okay, and so this particular system, which I think was also that Sandy Bridge system, for encoding, which may be a particular use case that you're looking at, you can see, okay, this is actually faster than most. It's a good system. Okay, and so if you're into gaming, then you've got games you can look at. If you're into database, you've got database benchmarks. Lots of different options. As we get more and more tests into the Phoronix Test Suite, then the sort of the value and the growth of the data is actually really, really exciting. Okay, so this is sort of graph that you may be used to before, where it's just basically drowning in a whole pile of numbers. What we're doing within open benchmarking is you turn around and you have the data presented with a set of heat maps with the system's performance put relative to that. So these are effectively percentile ranks, and so for this particular system, again, it's in the top top third of the systems that have been benchmarked. So you can have fairly high confidence that this works as a fast system in general. Okay, then there may be some other results which are a little bit slower, and so that raises questions and allows you to start thinking about, okay, well, is this a particular part that's relevant to me, or is there something else I need to look at? But one thing that we found is that going from this sort of format to this format, the amount of information extra information communicated is amazing. Because you can go, basically benchmark a system, switch to this view, which we're calling the open benchmarking performance classification, and you can get a very strong snapshot of what the system is good at, what it's bad at, and where it sits relative to other systems. Okay, and so looking a little bit deeper, so this is again a slightly different view. More data. You've got the system here performs very fast. It is a fast system. However, I/O potentially seems a little bit slow. Okay, so if you're doing I/O heavy work or you care about I/O performance, that's a big question mark. And also the file system performance was a little bit slower. Okay, obviously it's not purely hardware centric. There may be parts of the kernel or the file system that you're using that make a very, very large difference. And so what this calls out is if you can either have a system benchmark, or if, as the gentleman in the back was saying, if hardware vendors go and push data up for their systems on a regular basis, and we're already talking to people like System 76 to push data up, it makes it very, very easy for people to go, okay, here's a system, here's some hardware that I want to see, what do I expect it to be like?
So how do you deal with trust issues, right? People who, let's say I'm an evil ISV, right, and I write a driver, and basically I cut out lots of safety checks, and then my driver is amazingly faster, right? But I could never actually deploy it.
We shoot outliers.
so now I upload my corrupted data,
yes.
Right? And my system looks really, really fast.
But we're also in here accounting for outliers as well as other changes. Since we're monitoring the system logs, we'll be able to notice that. But of course, if you change it as well, your system log by default.
But if you look at the industry, so like say the workstation industry, you've got the spec OPC benchmarks. Okay, although they're not signed or anything like that, the penalty for actually falsifying or tuning incorrectly against the rules, you basically get blacklisted. And so we're hoping that the industry stays nice, at least for the moment, until we've got enough data. Because if you look at it, say, vendor A has got a system that's blazingly fast according to all the benchmarks, and then we've got another 5 systems that are virtually the same, they're completely different, they're either really, really good, or they've done something wrong. Okay, and as Michael said, outliers do disappear from this sort of benchmark. So, answer your question?
Yep.
Yep.
Also, if the vendor falsifies the information, it's going to turn around and bite them because you see those benchmarks, you take it home, you run the benchmarks again, and you're getting half of what they claim.
Right.
You're getting half
Yep.
of the same.
Which goes back to the make sure you've got a good return policy. Okay, but again, if you look at the collection of data, if we have say hundreds of thousands of pieces of data on different pieces of hardware, 5,000-10,000 for a particular class of CPU or a particular product, it's going to be very, very hard to gain that system because you've got so much other data that actually pulls it back.
Assuming they have it Spain.
Sorry?
Assuming they have it Spain.
Yes. Yeah, obviously the element of trust, but that's a process of cleaning and making sure the integrity of the data is still there.
And we're also checking by IP addresses as well to make sure that there isn't someone with like 10,000 result uploads all from one IP.
Okay, so some of the things that we're looking at doing to get lots of data is, having sort of pseudo competitions. When I talk about OPC a little bit later, where people push the data up, and when basically we work out some award for being the 33rd percentile system and the 66th percentile. Okay, and so again, that doesn't sort of reward going for the fastest or the slowest. It's like, where do you fit within the mix? And so again, when you have more data, it becomes a lot harder to gain it. Okay, and if we get people actually gaining it really, really hard, we'll probably succeed it anyway, so it's a good problem to have. Okay, any other questions before I move on? Okay, so imagine the scenario where you are looking at buying a piece of hardware and you're going, okay, I want to get a good feel for the way the hardware works. You do the search, you find the hardware, you pick up a result, then you want to start looking at your particular case. So, in terms of the benchmark that I found here, to say you're doing some very shader-heavy 3D, say workstation, and you think the Unigine Heaven benchmark is a good proxy for the sort of work that you do. So we've got this, in the middle of the results page, we've got this blue box, and that's really where all the power of open benchmarking comes from, because you can look at the heat maps, which I showed before. You can compare performance, which the person at the back mentioned, is that you get a system, see how your system compares to the system that you expected to do, then you can draw the comparisons.
And as far as comparisons go, if you're not familiar with the Phoronix test suite, everything is standardized down to the test level in regards to ensuring like Unigine Heaven's running at the same resolution, whether it's using tessellation or not, and other graphical settings, rather than just comparing how else you want to do it manually. And there's also a MIME launcher for openbenchmarking.org. So you can just click the open benchmarking icon and it'll automatically launch the Phoronix test suite in the given configuration.
Okay, so you found a result that's interesting. Okay, you then dive down into, okay, what is the particular test that matches my particular behavior that I'm expecting? So you choose that. Okay, you look at where this particular system sits relative to the other systems in the database for that particular test, and you see, okay, so the 6870, which is a new card, is fairly fast. Okay, it's not the fastest, but it's still a good piece of hardware. Okay, that should be down, but anyway. When you've got a single result set, open benchmarking will look through its database and pull out benchmark results that match the same result set. So when you filter down to a smaller set, you then suddenly have a lot more things that you can directly compare to. So, this is an ATI card, this is an NVIDIA card, this just happened to be in the result set for that particular test. You select that and compare, and you end up with comparison. Okay, so this is where this really helps the decision point about, okay, product A, product B for what I want to do. Okay, and this sort of presentation we find is really useful for sort of making that quick snap decision. Okay, so this is really the bit that we're most excited about and believe will have the biggest impact in the community for sort of helping people work out what hardware to get. I'm about to sort of move into some other areas, so any questions on this stuff so far?
But I mean, this isn't necessarily just hardware, right? I mean, you could be saying what file system should I use?
Yes.
Right, it's fully abstracted out to basically be testing whatever you want. Yeah.
In this list, you distinguish open and closed drivers, such as an upstream NVIDIA proprietary driver and maybe something from
The driver is recognized between the different ones, but right now it doesn't say whether it's open or closed. Since everything is fully automated, there isn't anything manually being done right now. Obviously, I could add that later where I add in a little description of what this driver means if it matches that, but not at this time.
And likewise for the search criteria, you saw one of the first pages. Although we don't have that in the system yet, what we're going to allow people to do is begin to sort of drill down. And so if you have a particular driver or a particular operating system you want to see, you can really focus on that.
And also within the search results as well, you can comment on there or ask questions. Another capability is that if you ask a question about, say, the Radeon HD 4870, it can optionally email everyone who opts to be emailed that actually has a Radeon HD 4870 with that question. So if you have a question about like anti-aliasing or anything else, then they'll be able to be proactively notified rather than forums or hardware lists where it's a hit or miss.
Okay, so moving on, and so as was mentioned, this isn't just hardware. Obviously, the primary topic for this presentation is all about sort of making hardware decisions, but within the Linux space, you've got compilers, you've got kernels, you've got tunables, you've got lots of different options. So you can also very easily compare a whole pile of compilers. It's a particular benchmark that you care about, and so this is a graphics magic color space conversion test, and this was this one that you did?
Yes, it was with AVX.
Yeah, and so you can see, again, this is visible in open benchmarking. You can say, okay, well, baseline on GCC 435, and we can see that 4.6 is 50% faster, and using the 4.6 optimizations that are targeted to Sandy Bridge is actually a hell of a lot slower. And so, it moves definitely beyond hardware. We're focusing on hardware initially, but there's all sorts of vastly interesting data that we can go through.
And since the Phoronix test suite is fully extensible, obviously, even though we're caring about performance and everything else, you could even be comparing on openbenchmarking.org, like some functional unit tests if you want, for like say XBMC with image quality rendering or anything like that.
Okay. Then again, once you have the data and you begin to explore once you got your piece of hardware and you begin to explore the data around it, you can then pull up other interesting pieces of information as well. And so, in this case on ATI hardware, you've got you can see a band matching the colors, so primarily the catalyst driver against the drivers, the various open source ones that are available, so Gallium 3D and I don't think it's MESA.
Yeah.
And so you can see how things perform relative to different drivers and the impacts that they have.
That was my point.
Yeah, yeah, but there's lots of ways we can pull it out. You can either do comparative benchmarking across the different hardware, against the different drivers, or you can, different people do different results. Like there's a guy that has been uploading results on a daily basis, probably the last 2 or 3 weeks, and he's tracking different Radeon open source driver variants, so LLVM, Gallium 3D, MESA. And so the next slide, actually, probably one of the previous slides where I had the clustered data, that's the sort of information that you'd see there. Okay, so some of the future things that we're looking at, and this is really to really solidify the analysis around the different characteristics of hardware, is we're calling the open benchmarking performance classification. Suite. And the intent there is it's a standardized suite that will look at the primary dimensions of a system, and so you can see, okay, memory speed, I/O speed, raw CPU grunt, OpenCL processing speed, and so it will give you the idea of a snapshot of what the system is doing, or how the system performs, so that you can make a better decision. It's intended to be sort of a time-boxed, targeted suite that will allow you to run it within a fairly small amount of time. But the if you look at the Phoronix test suite universe set, you've got literally days worth of testing if you want to run everything. So targeting it down to a small set of system characterization suites is something which is very important. Okay. Executing the suite is, who here has used the Phoronix test suite before? Okay, so it's available in most distributions. What you can do is just, Phoronix test suite space test or benchmark their equivalent and a suite name, and that's it. So that will download the benchmarking, all the benchmarks that are needed, compile them, set them up, run them, and then push the results up if you permit the system to do it. And so it's really lowering the bar down, so you don't have to you go and do massive configuration or try different things and then write a blog post about it. You make sure it's updated to the version 3 of Phoronix test suite, run the command. When it says, do you want to upload, you upload, and then your data's in there and you'll have a reference to the data so you can then go and slice and dice and compare your system. Okay. What we also want to do is on a probably quarterly or every 6 months is come up with a sort of snapshot of what the performance of the general sort of Phoronix test suite community, where they're sitting. And so that you can look at, okay, this is a fast system now, a new generation of CPU comes out, where does it sit? Okay, because we've got the pricing information for some of the products, if you've got a targeted test that's focusing on a particular product, then you can look at the bang for the buck, or the, what's for the cent? I don't know. What we'd call that.
Because of the ways you can slice and dice it, you can be looking at the graphics card performance relative to what it costs for the open source driver or closed source driver, but it's not limited to any general terms.
Okay, qualification, getting back to the question about, say, USB printers, this is something we've been talking about for a while. We've now got the pieces that allow us to do it. Moving beyond benchmarking and moving into actual looking at functional testing, making sure that suspend, resume, all the different things that the hardware compatibility lists and certifications that a lot of the distribution vendors do. Expanding that, standardizing that, making it generic. So you can, if it's a system like OEM vendors, they can go and push results, a certification suite result up to open benchmarking. You can begin to slice and dice and understand how that system works. Okay, so once we have enough data, what we're really excited about is you have enough data, you have enough statistics, and this is where we're going to be brushing up a whole pile of old maths books, is that we should be able to get data, look at differences between systems that are similar, and work out where the tunables and the performance impact is. So you can effectively say, okay, I want to sit within here, this particular performance range for a particular benchmark, and build up a system that supports that from where you are. And so that would be basically diving through a set of a use case where you go through the website in different ways to gather the data and pull it together. And then you're effectively building a system. You get down to the set of components, and if you're upgrading a system, potentially the price for the upgrade, according to the wisdom of the internet, or a full system and what you expect. Okay, we're speaking to some of the other, this is moving completely away from sort of benchmarking hardware and looking at what we've created with open benchmarking. Okay, who here runs an open source project? Okay, who here runs a software project professionally? Okay, one of the problems that a lot of people have is the available hardware is what you have around you. Okay, or you have to communicate with users and deal with users in fairly abstract ways, trying to get them to give you the information. So you end up with wiki pages with user contributed data. One thing that we've got, which is very easy to do now, is that you define a suite and you give your users the suite command that you want to run, and you can effectively crowdsource your testing. So you have 50 or 100 users that are interested in contributing. They don't have to go and run benchmark and set up their system. They run the command, the preparation of the test suite, and the downloading the parts and compiling those and setting them up right. Okay, that's hidden from the user. And so you can end up with, if you're a large project, you can say, okay, we're rolling out this change, it's sensitive with some drivers. Please, community, go test. And if there's performance problems or functional problems with, say, OpenGL drivers, you'll get that information back. I don't think there's anything available within the open source community that allows us to do that. And so that's something really powerful and something that we're working with a couple of the projects that are here today to see if we can enable over the next few months. Okay, yeah, so the main